Evening, Red Devils Chemists. It's Coach Scott here with another edition of Red Devil Chemistry. All right, so guys, we're going to continue to work on Worksheet 4S. Let's look through problem 12 through 14. And again, these aren't too bad. You guys have these. All right, now these are more empirical formula problems. Let's check them out. You have a compound containing silver and chlorine that has 75.3% silver. What is the empirical formula of the compound? All right, so if I subtract, and I assume I have 100 grams, and if I subtract 75.3 from 100 grams, so 100 minus 75.3, oops, 3, that's 24.7% for the chlorine. So Cl is 24.7%. So I know my percentage of silver. I know my percentage of chlorine. So now I can assume we've got 100%. So let's see. Remember our little chart we set up? Let's set one of those up. Alright, so I'm going to put silver and Cl because that's how we're going to get our empirical formula. Right? So silver has 75.3%. Write that down there. And this has 24.7%. And if you recall from our little template, we're going to write the mass, the atomic mass of silver here. That would be 107.87 grams per mole. Chlorine, oops, put an L there, is 35.453 grams per mole. All right, so now I've got to divide this by that on both charts, and that's going to give me the number of moles. So if I take 75.3 divided by 107.87, I'm going to get 0.698 moles. If I take 24.7 grams divided by the mass, the atomic mass of chlorine, 35.453, I get, oh, guess what? 0.697. All right, what I would do next, normally, if I need to, is I'm going to take the lowest amount of moles. I need to make these our whole numbers, right? If you look at these are essentially the same number. So that was officially the lowest number. If I divide that by 697, I'm going to get 1. And if I divide that by 697, the lowest number of moles, I'm going to get 1. So that tells me that the empirical formula of silver chloride is AgCl. I'm done. Easy. So let's look at this one. In a vigorous chemical reaction, 1.403 grams of sodium metal is completely reacted with 1.159 grams of fluorine gas. What is the empirical formula of the compound? So let's see, we've got sodium and we have fluorine. All right. So, okay, so I don't have to assume anything about using percentages. I could. Well, it really doesn't give me enough information to do that. So now I've got my mass, right? I've got my mass. So we're going to do the same thing. But this time we're going to write the actual mass, 1.403 grams. Okay. Then I had 1.159 grams. And notice it says completely. This is not an excess reactant problem or a limiting reactant problem. It is an empirical formula problem. So now I've got to get the atomic masses of sodium and chlorine, 22.99. The atomic mass of fluorine is 19. Nice and easy. So again, just like above, divide. Okay. So 1.403 divided by 22.99 is going to give me the number of moles, and that number of moles is going to be 0.0610. Let's do the fluorine. 1.159 divided by 19 is going to give me 0.061. We're done. And it makes sense too, because sodium is a group 1 metal, fluorine is a group 17 non-metal, plus, minus, yeah. So that is our empirical formula. But we're going to show we know what we're talking about. If I take the lowest one there and divide that by 0.061, I'm going to get 1 moles. So that's that one. We're moving along pretty good. Let's go look for the next one. All right, our next one. What is the molecular formula of a hydrocarbon that has the empirical formula of CH and a molecular mass of 78 grams per mole? So let's go ahead and write our CH, the empirical formula. Right? So we need to find out what the empirical formula, right here, of carbon and hydrogen. So carbon is 12.011 and hydrogen is 1.0079. It's from the periodic table. If I sum those together, I'm going to get a empirical formula mass, of 13.0189 grams. So it gave me the molecular mass, or the total number of carbons and hydrogens, of 78 grams per mole. If I divide the empirical formula mass, 13.0189 grams per mole, I'm going to get a factor. So I take 78 and I divide it by the empirical formula, 189, and I get a factor of 6, or 5.9996. So that means I've got to take CH, multiply it through both sides by 6, which is going to give me a molecular formula of C6H6. Done. By the way, the name of that is benzene. So those are 3 problems. Those are problems 12 through 14 on worksheet 4S. Guys, I hope that helps you out. So this is Coach Scott with Red Devil Chemistry saying sayonara. That means goodbye.